Hi, today we're going to be working with logarithms, but a special type of logarithm using a number e. So you all know pi. Pi is an irrational number that never ends, and now you're going to learn a new value. It's called e, and it also is just like pi. It's a set number, it's irrational, and it goes on forever. You don't have to write down all the digits up there. If you want to write down the first 5 or so numbers, that would be great. But the e is the irrational number 2.718288182 blah blah blah. And when we use a logarithm and we have a base of e, most logarithms, you know, the regular base is 10, although you can have different bases. Your default base is 10. A natural logarithm, the base is e. So a natural logarithm is a logarithm in which the base is the irrational number e. In the box, I show you all the three representations. They all mean the same. So the first on the left, e to the x equals n. The base is e. Then you have your x power equals your n value. And that's the same as saying in the middle of the box, log base e of n equals x. So log base e, because e can be any, or the base can be anything, e, 2, 10. And then at the very right, you see this ln. ln is the natural log. That means log base e. So throughout this entire lesson, keep in mind that anything you learned about logs, all the properties, you're changing forms, you know, your log rules, how you can expand and condense, those all apply here. Okay, so where is e on your calculator? So problem number 1, you have to find the value of each of the following when x is 3. That's the question. And then you're going to round to the nearest hundredth where it applies. Okay, so if you have to put e to the x in your calculator, that means we're going to raise the number e to the x power, and we're going to have x being 3. For your work, you would just show the 3 substituted in. And then to find e on your calculator, all right, on the Inspire calculator, you're going to find that pi key symbol. And then when you hit that pi key symbol, you're going to have those 6 boxes in there. The e is in that on that button. On the 84 calculator, there's 2 places to find e. It's on the ln button right here. Okay, e is above that button. That means you're going to press the blue key. So second ln, and that will get you to your e. And that specifically is that special number, 2.718. All right, we're going to put a 3 in. And then there's your answer. Now, also on the 84, there is one other place to find an e. It's on the division key. Again, it's a blue e, so it's going to be second. Now, that e is different from the green e. The green e right here, that's actually just the variable e. This e that on the division sign, that actually is this e value. So you can also do second divide and then do a power 3. Either way to do the e is fine. Okay, so rounded to the nearest hundredth is 2 decimal places, so that's 20.09. All right, so e to the x ln x power. So first filling in, that would be my work. Now, e and natural log, remember if you change forms, base and logs, those are inverses. So e and ln actually are going to cancel each other off. So you're going to see that this is going to come out to be a nice value. So we have e to the 3, and then ln will be on your face of your calculator, and then another 3. And this is 27. What's happening is the e ln of 3, if I apply that power first, actually is a 3 because e and ln cancel, and then 3 raised to the 3rd power is 27. So that's what's going on, but you can just use your calculator. And then one last one. So we have ln of e to the x power. So we have ln e to the 2 times 3 power And again, ln of e cancel each other off. So you're going to see that this will also come out to be a nice value. And you get 6. Okay, so now we're going to do some solving. So these are evaluating questions because you were just finding values for them. So we have 2 types. We have the example 2 where you're solving when you're working with exponential form, and that's base e. And then question 3, we're going to be working the other way where we have the logs or ln's in the problem. Again, all the rules that you've learned in the past apply just like you would solve an exponential. So 2a, if I want to solve an exponential, you could try to do like bases, but you can't with ease. So that is out of the way. So there's 2 options that you can do to solve for a. And we'll show you both of them now, and then you can choose whatever way you prefer better. Okay, so option 1, and I'll make sure I follow my options over here on the right. Option 1 is you can change to log form and then evaluate. All right, so log form. Log, the base is e, the outcome is 72 equals x. Now, I want to show you some options. You can actually, at this point in time, put this in your calculator. So you can do log base e. I'll show you what that looks like. Alpha window, or on your whatever way you do on your calculator. You're going to put the e. Now for this one, you definitely want to do second divide on the 84 because you don't want to put a power. The second ln e will give you an automatic power there. And then 72. And then you can just evaluate. And there you go. Now log base e, and if you look it up or Google it, you're not going to really see this. This is not standard. What's standard is to replace log base e with its more common form, which is ln. Again, you don't have to make that change. You could just change forms and do what we just did. But just to show you, ln of 72 means the exact same thing. It means log base e. And you get the same exact value. So whatever way you want to do it. But this is changing forms. That's what I mean by option 1. You can change forms and evaluate. Okay, so x equals 4 point nearest hundredth. So 4.28. Okay, the other method, and I apologize, I'm going to run into this space. The other method that we can do, option 2, is we can take the log of, or the ln of both sides. When we did logs, we could take the log of both sides, but the opposite of e is to take the ln of both sides. So this is what this would look like. You would take the ln of the ex side, and then you would take the ln of the 72 side. So sorry, we'll do that over there. Then what happens is the power rule means I can put that out in front. And then to break apart times to get the x out of the way, I can divide ln of e over. That will cross these off, and then x equals whatever that value is. Now it's the same problem, so you'll see that we're going to get the same exact answer. Okay, so all of those ways are how you can answer these problems when you have a base e. Okay, so that was option 1. Option 2 is to take ln of both sides. Okay, so I don't mind whichever way you prefer. I will tell you that method 2 is the more standard way that you're going to see in textbooks, because as I already told you with logs, not all calculators have a log base key. So you wouldn't be able to do this, but you can do this in your calculator. All calculators, all scientifics have an ln key. Okay, so for part B, I'll only do it one way. I know the majority of you guys are probably going to like method 1 better, so I will do it that way. On this problem, think about what you have to do to get to x. Right now, I'm not going to change forms because that 2 is in the way. So to break apart a times 2, I'm going to divide the 2 over. Okay, at this point now I can change forms if you want, or I can take the ln of both sides, but I'll change forms. So we're going to have log base e, the 62 is the outcome, and this whole guy is the exponent, so 3x will be on the other side. All right, now again, I can put it in my calculator right now, but I'm just going to change log base e to ln. And now it might seem a little bit nicer what to do. I still got to get x by itself, and to break apart times, I divide. So now I can just go ahead and put ln of 62 divided by 3. Now if you wanted to put log base e of 62 and change that to a number, that's fine. But please be careful to keep the entire decimal until the end of the problem. If you round too soon, too often, you'll change your value at the end. Okay, so rounded to the nearest hundredth again, it's 1.38. All right, so your base e's again, you can either change forms and evaluate, or you can take the ln of both sides, bring down your power using the power rule, and then divide terms over like normal. With example 3, now we have an ln in it. So again, just think about what you would do if you had a log in it. Problem number 3a, you have a choice. I have to first get rid of this 4. You have one of two options. You can either bring the 4 back up here as a power, because that's what that is, or we can also get rid of it by dividing it over, because this is multiply, so I can also divide it over. I think I would rather do that rather than working with a 4 power there. Now you can change this to 0.5 or leave it as a half, whichever. Okay, so when we were doing logs, we changed forms. So now we are going to change forms and put it back in exponential form. And if you recall, ln means that there's an e here. So the base is e. So this means e to the 1/2 power equals x. Now I'm going to move this down a little bit. Some of you guys may want to write ln first with a log. If it's in this form, then maybe you're able to convert it to exponential form better. Okay, so now once I did this, see, this was a little easier. X is already by itself. All I have to do is put that in my calculator. Okay, so I'm going to use my second ln because that gives me my power. You can use a 1/2. You can even make it a 0.5. That's 1/2. And so your answer, again, I'm just generically making you guys round to the hundreds, but please make sure you read directions, that you round appropriately. So x is equal to 1.65. Okay, so B, same thing. I can't work with the ln until I have that only by itself, so I have to get rid of the 2. Again, I can bring the 2 up here as a power, but that will make it a lot trickier to work with. So in all honesty, it would be better to divide out the 2, because I just have to get rid of it somehow. All right, and then 7/2, you can leave 7/2. You can write 3.5. Okay, so now we're going to change forms. This means that there's a base e, so e is the base. 7/2 is the power, or 3.5, equals all of that value. All right, at this point in time, you can either A, change that to a long, nasty decimal, but I would rather hold off, and I would rather get the x by itself. I have to first add the 4 over. And again, you can change this to a decimal at any step, but I would rather not write that all. So now I'm going to wait. I got to get rid of the 3 by dividing, and it's that whole side. So at this point, I now have x by itself, and now I can just type that all in my calculator to get my final answer. Again, I could have wrote 3.5 here, but I'll show it to you as a fraction. Just make sure you get out of that exponent. And your answer is 12.37. All right, we'll try one last problem. And I'll raise up my oops, sorry. Okay, letter C, one last one. Notice we have 2 logs. So just like before, 2 natural logs. Just like before, we have to condense it into 1. So now you have to recall your rules. When you're adding 2 natural logs or logs, you can combine them by multiplying the 2 insides. So this all condenses to ln of 4x. Okay, once I do that, I now have 1 log, so now I can change forms. There's a base e here. Again, if you have to write it like that in order for you to figure out how to change forms, that's fine. But base e, 2 is the power, equals 4x. I can type this in my calculator now, but I'd rather wait. I want to get x by itself by dividing the 4 out. Now I'm done. X is alone, and I can just type e to the second divided by 4 in my calculator. And it's 1.85. And as I've already told you in the past, you can do any solving problem using your y equals key. If I just show you this, I'll just do it on this last problem. You can do ln of x plus ln of 4. And then you can do 2 on the other side. You could graph it. And then the answer is a long decimal. When you're working with these, most likely the answers will not be pretty. So don't bother going to your table. I'll do my intersection way. And there again is 1.85. So keep that in mind if you want to use this as a way to check, or use it as an alternative method if you are having problems with your algebra.